Dear audience, I would love to present you the study on an aerodynamic phenomena scientifically known as Coanda effect. And I will explain you how the Coanda effect is related to the good indoor climate. In this presentation, I will go through the basic examples of an air distribution in premises and how does it affect humans' comfort. I will introduce you to some issues related to an unsatisfactory indoor climate, and when this is clear, I will proceed with explaining the Coanda effect and where can we actually observe it and why the Coanda effect is so important in ensuring a good indoor climate. And to round it up, I will present the smoke test results that will clearly demonstrate the importance of Coanda effect in ventilation systems. The main concern in ventilation air supply is that it is not an easy task to make everyone feel comfortable. Due to such factors as unevenly distributed air supply, heat loads, or the incoming solar radiation through the window, everyone will be exposed to different indoor conditions. So somebody will feel warm, like this guy here, and somebody will feel cold, like those two. And human perception of comfort is individual. So somebody prefers colder temperature, somebody prefers warmer temperature. And to see some examples of an unsatisfactory air distribution, let's take a look at the next slide. Well, quite common picture in our parliament, I guess. But I'll tell you something. It's not always because of them. It is sometimes because of bad ventilation. Seriously. Let's take a look at the sleepy guy. Okay. Yeah, let's take a look at the sleepy guy. If the ventilation supply is not sufficient, the carbon dioxide levels in room will increase, and thus it will make a person feel tired and dizzy, and it will lower the person's productivity. Generally speaking, CO2 levels indoors should not exceed 1,000 particles per million, and in our parliament, as you may have concluded, CO2 levels exceed 1,000 particles per million. So now let's take a look at the angry guy. What's the problem here? Excessive amount of air supply can cause a draft when the air drops vertically on your head, and that can make a person feel uncomfortable, dissatisfied, and sometimes really angry. So here's a question. Can we actually do something about those two above-mentioned problems? And the answer is, yes, we can. With a proper ventilation system design, you can make a person feel comfortable, productive, and happy. So, when supplying fresh air into the room, the general issue is to keep a good comfort level within the human's occupancy zone. And when supplying cold air into the room, when supplying air into the room through the diffuser, the negative pressure occurs between the air jet and the ceiling surface, thus causing the air jet to stick to the ceiling and flow along it. This phenomena is of great importance in ventilation systems, and particularly when supplying cold air. The phenomenon derives its name from a Romanian-born aeronautical engineer Henry Coanda. And very simply, the Coanda effect or wall attachment is the tendency for moving fluid to flow along the surface, to stick to the surface and flow along it. And where can we actually observe the Coanda effect? The Coanda effect can be observed when we're doing our daily household tasks like pouring water out of a pitcher and the water sticks to the pitcher. It can also be observed when we supply ventilation air into the room, so the air sticks to the ceiling. And it can also be observed when the plane takes off the runway. So actually, it is Coanda effect that helps to lift our planes and to take us overseas. To determine and analyze the Coanda effect, a full-scale test was conducted with a specially designed test chamber. The test chamber represented a typical single office room, and the test was based on international regulations. This is the layout of a test chamber. Okay, this is boring. This is a picture of a test chamber, and you can actually see me very serious and very concentrated trying to set up a thermometer before running a test. And now we'll proceed with some with the diffusers that we tested. So the four most common types of air supply diffusers are these, and diffusers are specifically designed for different applications. So some of them perform better when supplying cold air, some perform better when supply warm air. And here's a smoke test result for a plain diffuser. And on the left side, you can see that air drops down vertically because of insufficient airflow rate. And on the right side, you can see that the air sticks to the ceiling and flows along it. So airflow supply was increased, and therefore allowing to air be distributed radially. Here's another type of diffuser. It's a swirl diffuser. And again, on the left side, you can see a good swirl effect. However, the air still drops down vertically, causing discomfort in the human's occupancy zone. On the right side, you can see that Coanda effect is achieved either by increasing airflow rate or by adjusting the blades in the diffuser to ensure a good air distribution pattern and to ensure good comfort level within the human's occupancy zone. And here's the smoke test result for another type of diffuser. It's a flush-mounted plain diffuser. Again, the left side, due to some improper ventilation design, there is a draft rate in the human's occupancy zone. Basically, it's discomfort. And on the right side, we have achieved Coanda effect. I have many of those, but we'll not take a look on all of them today. So basically, I'd like to say that even if my presentation was too difficult or a little boring for somebody, at least you have learned one thing, that Coanda effect means good indoor climate. And if I still have 1.5 minutes, I would love to demonstrate something, and it will be really fast. I just have to choose the right. So while I'm setting this up, I would love to thank you, the supervisor of my doctoral thesis, Anatolijs Borodinets, and I would love to thank Systemair for lending us this wonderful device. So now I've been talking a lot, but now actually I will demonstrate you something. If we just let the air flow into the room without adding a diffuser, so imagine like the tennis ball is a diffuser, air supply unit. I don't see here any, but anyway, air supply unit. If we just allow the air to flow into the room without the diffuser, so this is the fan, this is the air duct, so we'll see that I would love to add some smoke to it, but here's a sprinkler, and I'm afraid that the smoke will activate the smoke detector, so we don't want to get into trouble. But you see that air flows uncontrollably, and if this is a ventilation system, then in the human's occupancy zone it will create draft, and somebody will get really angry, like one of those guys in the previous slides. But if we add a diffuser, you can see the diffuser acts like an obstacle, so it allows the air to flow radially without causing the excessive air velocity or draft rate in the human's occupancy zone. So diffuser ensures, generates a quanta effect in the room, and that's why it is so important to achieve the quanta effect in the room, so the air flows radially and along the ceiling and ensures a good mixing and good indoor air quality. In good indoor climate we trust. Thank you.